Designing an underground residential complex requires careful consideration of several factors. Geotechnical conditions are paramount. Soil-bearing capacity and stability must be assessed. The soil composition should be analyzed to evaluate the risk of liquefaction or settlement. It is important to determine the groundwater level and the potential for flooding. Building code requirements must be adhered to. Ensure compliance with the International Building Code or relevant local building codes for underground structures. Fire safety regulations for egress, ventilation, and smoke control are essential. Seismic design requirements should be followed, particularly in earthquake-prone regions. Ventilation and lighting are critical aspects. Mechanical ventilation is needed to maintain air quality and prevent moisture accumulation. Consider using natural light through skylights or light walls where possible. Implement artificial lighting using energy-efficient fixtures. Waterproofing and drainage are vital to protect the structure. Use waterproofing membranes and coatings to prevent water infiltration. Establish drainage systems to evacuate groundwater and storm runoff. Humidity control is crucial to prevent condensation and mold growth. Thermal insulation and energy efficiency should be prioritized. Insulation helps to minimize heat loss or gain. Implement energy-efficient design strategies such as passive solar heating and geothermal heating or cooling. Consider incorporating renewable energy systems like solar panels or geothermal heat pumps. Access and egress must be carefully planned. Provide underground parking and entrances. Design safe and convenient stairways and elevators for vertical access. Ensure emergency exits comply with building codes. Safety and security are essential. Implement security systems and lighting. Install emergency lighting and power backup systems. Integrate smoke and fire detection systems. Implement access control measures for security and privacy. Construction methods require specialized expertise. Employ appropriate excavation techniques such as cut-and-cover, tunneling, or diaphragm walls. Utilize waterproofing and structural reinforcement systems. Use specialized construction equipment and expertise. Additional considerations include permits and approvals, community engagement, sustainability, and cost-effectiveness. Obtain necessary permits from local authorities. Ensure community acceptance and support for the project. Design with environmental considerations such as energy efficiency and water conservation. Assess the feasibility and financial implications of the project. The American Society of Civil Engineers offers an underground structures design manual. The International Tunnel Association provides guidelines for the design and construction of underground structures. The National Institute of Building Sciences offers a whole building design guide for underground structures. Careful planning and adherence to these considerations will help ensure the successful design and construction of a safe and sustainable underground residential complex. It is important to go over building codes carefully when constructing any structure. In an underground structure, egress, ventilation, and smoke control is very important. Also, it is important to have seismic design if it's needed. Make sure the lights are energy efficient, the parking is easily available, and that there are elevators and stairways in case of emergencies. There needs to be lights in case of emergency. Smoke and fire alarms and access control for privacy and security need to be present. The environment needs to be taken into consideration, and the cost needs to be assessed. There are documents from different sources for all the different types of rules and guidelines. Keep in mind that the type of soil can impact the building. The groundwater level can also impact the construction as well as flooding. You can use natural light through skylights. You need to use waterproofing and ways to prevent water getting in. You can use solar panels as renewable energy. You also need to think about gaining access and exiting from the building.